All right, section 10.3, just a continuation of 10.2, is displaying data part 2. And what we're actually taking a look at is some different other kinds of graphs. So the first one we're going to look at is a line graph. A line graph has line segments connecting one data point to the next, typically showing the trend of a variable over time. And you should think about when you were a child, or maybe you've been playing with your nieces and nephews or brothers and sisters or whatever recently, and you think connect the dots, okay? So when kids first learn to connect the dots, they do it with straight edges between things, so it ends up looking a little bit boxy, you know what I mean? That's what a line graph looks like. It looks like a bunch of little bitty segments drawn straight between them. There's no curving going on here. All right, so here is an example. A learning specialist tracked the average reported study times for her students. Create a line graph for the data she tracked. So these are the hours, it says the times of studying. So on Monday they studied 1.5 hours, Tuesday 1.75, Wednesday 0.75, and so on. Okay? So we're going to create a line graph for this information. So in order to do that, we're going to draw that XY axis that we have been using for our histograms and bar graphs in the recent lesson. And we're going to, again, make that mention right here at the beginning that we have a break in the graph. This is categorical data. Notice all of the information is given as sort of descriptions, Monday, Tuesday, right? So down here on the graph down here, we're going to have each of my marks as Monday, Tuesday, Wednesday, Thursday, I'm abbreviating now, Friday, Saturday, and Sunday. Again, they need to be roughly equally spaced. Don't go sticking things too close together or too far apart. Yes?
Why do you have to do the bump at the beginning of the graph? Is it harder than beginning?
Well, it probably depends on whose calendar you look at, right? We just indicate that we're not starting at 0. In other words, what we're really indicating, this is what we really are indicating, is that the y-axis has no concrete values. It has no meaning. Whereas normally when we work within an XY axis like in algebra, the y-axis means x equals 0. Well, x equaling 0 doesn't have context in this particular problem. So the y-axis has no concrete context. Yeah.
So basically do it every time?
Occasionally you won't, because occasionally you might actually have something starting at x equals 0, and so you wouldn't need to. But probably, I would, more often than not, we probably don't. So we probably would have that bump there, yeah, that sort of break in the graph. All right, and then we've got data values. The smallest one's what? 0.25, and there's a couple of those, and the largest one is 2 hours. All right, so along my axis on the left, I need increments of 0.25s, right? Because everything is in terms of quarters of an hour or 3. Okay, so I think I've got 8 of them there, so that would actually take me up to the 2-hour mark. I know I'm going to be running into my graph itself, or my data table itself, but that's kind of the best I can do right now. All right, so we've got something like this. I'm not going to mark every single one of these because I don't have really the space to do that, so I'm going to mark every other one. 0.5, 1, 1.5, and 2. And along the horizontal axis, rather, what are these? Horizontal? These are the days of the week. What is my vertical axis this time? It's hours. And it's the hours they've been studying. All right, so we're going to plot a point, not a bar this time, but a point at each one of these heights. So on Monday, we need a point at height 1.5. Like so. On Tuesday, we need a point at 1.75. On Wednesday, apparently a number of the kids went to church, so they studied less. 0.75 down here. On Thursday, they had a test coming up on Friday, so they studied more. So mine's going to appear right in the middle of this box, unfortunately. Maybe yours will look a little bit better because you won't be drawing on the same screen. And then on Friday, I think somebody lied because I'm pretty sure none of them studied on Friday. But we'll give them the benefit of the doubt and put it at 0.25. Saturday, also 0.25. And then on Sunday, of course, they're getting ready for the week ahead, and they studied another 1.5 because they didn't study over the weekend. All right, and then what we're going to do is we're going to connect the dots, and we're going to connect the dots in order of how the dots appeared. So the Monday has to connect to the Tuesday, and then Tuesday to Wednesday, and Wednesday to Thursday, and Thursday to Friday, Friday to Saturday, Saturday to Sunday, and that's our line graph. So the first question I have to ask you is, where have you seen line graphs in real life? Because you see these ones a lot. No one knows. Stocks. That's usually the one people think about, stocks. They use line graphs with stocks. They showed these sharp jumps up and sharp divots down, and so stock market is a prime example of where you see this. You'll see it with other things too on market trends. The cost of a gallon of milk, and somebody will create a line graph that does that, or cost of a gallon of gas. So line graphs show you trends over time. All right, so this is one way to look at something and how it trends over time, is to connect them from point to point to point to point. Okay, so you have this sort of a very disjointed looking graph, right? It looks very, it looks like a roller coaster, I mean, right, to some extent. At least that's how we sort of feel like when we're looking at it, like, oh, look, we jumped really up and then we fell back down really fast. Okay, so there's another way to do these trend graphs. And that is with a trend line. Now, before we talk about a trend line, we're going to talk about a scatter plot. We actually already created a scatter plot. A scatter plot is simply the dots before you connect any of the lines. Okay? So we've already done this one. I'm not actually going to talk about this as a specific, but a scatter point is just the graph without the dots connected. Okay, so we already did that. A lot of times, if you've got too much variability in what's going on, and the last one was a pretty good example, it almost feels weird to connect them that way. To connect them with these lines that just go up and down and up and down and up and down, because it feels like there's not really any overall pattern. Okay? Usually when you start connecting dots, you're looking for sort of an overall pattern. Hey, look, over time, if we plot all the things, the weight decreased on the people in The Biggest Loser, right? So we can plot these dots and it goes down, and we look, oh, look, it all the way went down. Well, if there's not sort of a correlation of what's really happening over time, it feels a little bit awkward to connect the dots. So sometimes people will just display things as a scatter plot with no connections, okay? A third option then is to display them with a trend line. So I'm going to go to the next slide. We're going to come back to this one in a second. If you create a trend line, what a trend line is it's a line that closely fits the data and can be used to describe it. It's often called a best fit line. So what I want you to do is to go back to the very first graph that you did, this graph right here. And I want you to either switch color or make note to yourself that this second line you're about to draw is not this one. It's not a line graph. What we're about to draw on this same graph is a trend line. So it helps if you, or you can redraw the points if you'd like to draw the trend line. I'm actually going to erase my line here so I can talk about it in a way that makes sense. So for a trend line, you do the scatter plot, that is, you plot all the points. And then what you do is you take a straight line and you try to draw the line as best you can through this data so that it gets as close to as many data points as you can. Now, these data points are really spread out, so it's not going to be a great approximation of what's really going on. But if you were looking at something over time that was completely going downhill, like a weight loss situation on one of these contestant game shows, you'd be able to draw this line that would make sense because you'd see that decreasing sort of a movement in the weight values, okay? So if I were looking at this one, I might draw something that looks something like this. I'm trying to get to as many values as I can, or as close as I can. So there's 3 values above here. I've got 4 values below, and I'm awfully close to 2 of them, more or less. Yes?
Do you have to start at the 0, or can you pick a spot?
You can start wherever it makes sense to start, and sometimes it won't make sense to start with it being a 0. It also could be a graph that goes downhill, like with the weight loss example I was giving, right? So it doesn't have to be an increasing graph. In fact, one of the questions that was asked is, what kind of association is this? This graph right here, this association, is a positive association because the slope's positive. Okay? So over here where it says, what kind of association is this? Or is there for this data? It's a positive association. because the trend line is a positive trend line. Now we're going to do the data on this table next. I just wanted to show you first the data from the one we had before. So it was difficult looking at the first graph to actually draw a trend line or to even think, is it a positive trend line or negative trend line, because the data is just really odd, right? Okay, so let's use the data now in example 2, and we'll see that it's a little bit easier on this one to draw a trend line. All right, so find yourself some space. I'm not sure if I have space on this graph. I probably don't. Let me use another sheet. And we're going to take this data, which is about, is it long jumping? Yeah, not long jumping, jumping records, height. Coach Lewis kept track of the basketball team's jumping records over a 7-year period as follows. So from the year 2000 to the year 2006. We're going to draw a scatter plot for the data. And the question is, what kind of association is it? Yes?
I have a question on the last graph. Why wouldn't you draw your trend line starting at that first point and going down, because you did get more? I thought that I would go down too.
You maybe could. So you're asking, could you draw the line to go like this?
Yeah.
You probably could on this one because it has such a weak association to be able to be honest, you probably could draw it straight through the middle too. This one isn't a good example. I thought that I would be showing you something helpful. I don't think I did. The next one will be easier to determine. You'll see it'll make more sense. No. You can probably just draw it like that even. Look at that. No association whatsoever. I should make mention of the fact that if you have a positive slope, it's a positive association. If it's a negative slope, it's a negative association. And if it's a flat line, no association. All right, it'll make sense on this one, though. Let's do this information. So we've got the data values going from 65 up to 77 from the years 2000 to the year 2006. And we're going to start by drawing a scatter plot, which is just the dot representation. And then we'll end with drawing a trend line. On this one, I really need to not have that jagged point in there, that jagged up and down like you were asking about, Kristen. Because I'm going to have to create an equation for this line. And if I have that jutting up business, I can't create an equation for the line. It won't make any sense. So we got to figure out how to deal with that. So this will be the year, we'll start here with the year 2000. And how about we just let the year 2000 be the x-axis, or the y-axis right there. Is that okay with you guys? So we'll start there at the year 2000. And then 01, 02, 3, 4, 5, and 6. Again, they need to be roughly equally spaced. So you're going from the year 2000 to the year 2006. The high jumping records here, the jumping records, go from 65 up to 77. So it's fine for us to start also with this being 65. That is that the x-axis is the number 65. And then we can go up 66, 67, 68, 69, 70, 71, 72, 73, 74, 75. I'm running out of space. I'm going to try them a little bit closer together. How about I do them in twos? 7, 69, 71, 73, 75, 77, 79. So 77 is my highest one. All right, so the very first point that I'm going to plot is the point at the year 2065, which in this graph is the origin, right? Are you guys okay with that? The year 2000 is going to be the height of 65, which will mark all our axes in a minute, but let's just plot our dots for now. The year 2001 is the height of 67. 2002 is also a height of 67. 2003 is a height of 68. 2004 is a height of 70. 2005 is a height of 74. I think I skipped one on my axes when I labeled mine. I did. Sorry, this is 73. No, did I not? Oh, I just labeled 75 instead of 73. That's what I did. Okay, good. So 74, in 2005, and then 77 in 2008, or 2006, the last one. Okay, so at least on this one, there's no question that this is going uphill, right? Over time, this is increasing. That's a good thing. So we're going to draw our trend line. Now, my trend line is not going to look exactly like yours. Guarantee it's not going to work like that. However, we can draw it in there just fine. We're just going to try our best to get as close as we can to what we've got. Okay? So you need to look at this and draw it in such a way that it looks fairly close. I think I'm going to go with something like that. It's reasonable, right? There's definitely things you could draw me that would be unreasonable, but as long as you've drawn me something that's reasonable, we're all going to be happy. When you look at one of these on your homework, what they're going to do is they're going to give you a graph with a bunch of dots everywhere. What you can do is you can put your paper down on top of it, and you can actually trace it onto your paper, so you don't have to freehand it. That's going to be the easiest option for you, so that when you draw that, you get all the dots on your picture without having to speculate and be really precise. If you just use your paper as a like tracing paper basically on top of it, that will be easier. All right, the last thing on this one, though, it asks us are some information about this. It says create the best fit line for the data, which we did. We did part A. Part B says to estimate an equation for the trend line. That's something different. We haven't talked about equations very much in this class. In fact, I don't think we've talked about them at all. So we need to talk about equations. So what do you remember about equations? What's an equation of a line? There's lots of them. Somebody tell me one of them. That's the one people usually remember. In order to do y equals mx plus b, what do you need to have? The y-intercept and the slope. Good. We have both pieces of information on the graph. Now, my y-intercept actually looks like it's beneath 65. It's not really negative, right? Because my x-axis is the 65 line. So this looks like it's probably crossing at maybe 64. Does that seem reasonable to you guys? Are you okay with that? Yours may not look like it's crossing at 64. Maybe it looks like it's crossing at 65. That's fine. Then you can use that as your b value. So mine looks like 64. The slope. How do we get slope? Well, we can get slope in several ways. One of the ways we can get slope is we can do it by counting. And we have to do it along the line. We can't use the red dot points because the red dots are not on my curve for the most part, right? They're not on the line itself. So we have to actually use values along the line. So let me use green here and pick some values along the line. Now I am assuming from my graph, whoops, didn't mean to do that, that this point right here was the point, the year 2000, and the y value of 64. So I can pick another value. Let's say I pick right here the year 2001. Looks roughly like a y value of 65. 6, sorry. Get the number in there right. 66. So I can use those pieces of information to find slope. And you can use any of the 2 points on your graph that you'd like. So if I hadn't wanted to use that one, maybe instead I decide to use the year 2006 and say, look right here at year 2006, it looks like I'm at about 74. So I use the year 2006 and the number 74. So I could use down here 2006 and the number 74. I'll use that now just since I rewrote it. Okay. So how do you find slope? Do you remember the formula for finding slope? It's rise over run. So it's the change in y over the change in x. So my y values are the heights now. So that's the 74. So I'll do 74 minus 64. And the run is the 2006 minus the 2008. 2000. So if I do 74 minus 64, what do I get? 10. 2006 minus 2000 would be the number 6. And if I keep it in fraction form, this would actually reduce to 5/3. If you write it in decimal form, you're going to get a repeating decimal, which is fine. You can use a repeating decimal in here too. I'm going to write minus 5/3 x here, or 5/3 and then times the x. You may not get 5/3. On the sheet, that was my note sheet that I'm teaching from, I don't have 5/3. I have 4/3. And I got a y value of 65 and not 64. All right, so it's going to vary from paper to paper, but it's going to be close. If you tell me that your slope is 3, we're going to have issues. 3 is not close to 5/3, right? If you tell me the slope is negative, we're going to have really big issues because this slope is not going downhill. So there are definitely things that are legitimate, approximations, and there are things that are definitely not. You do need to make mention of one thing, though. We need to finish our graph, but we need to make mention of some information about this equation. Let me finish the graph off, and then we will go back to the other slide where we were writing information down. What are these 65, 69, 73s? What are these? On the information you were given, what were those numbers representing? They're what? The record what? In jumping, in what units? Inches. That's a very important piece of information. I want to make sure that we know we're talking about inches, not feet or centimeters or something like that, right?
So, do we need any, really on the titling the y-axis?
What? I'm sorry. One more time,
Do we
Kristen.
need to be really specific? Like, I've always been told just to be like, put the year, record, inches, but do we need to put like more?
No, that's fine. You can be fairly general, but you're definitely going to have units for it to make sense, and to have some sort of a sense that this is, like you said, it's a record jumping. This is about jumping. It's not about running, something like that. So these are the jump heights. And you need to have the inches part in there somewhere. And then down here, like you said, this is years. And then your title, I'll put mine down here in the corner, is these are the jump record heights. Let's talk a little bit more about this equation now. We actually put all the titles and everything in, so we actually finished the graph. Let's talk about this equation. So what I found on this particular time when we went through it is that y equals 5/3 x plus 64. This is the inches. That's what we're actually getting out of this equation. Answers that come out of this equation are inches. And we need to actually write down somehow, this is x years after 2000. And that's probably the most important piece that people tend to forget. Because if you don't tell me how x is measured and I ask what happens in the year 2012, how do I know what number to put into it? If you're measuring since the year 2000, then the year 2012 goes in as the number 12. If you're measuring since the year 1950, 2012 doesn't go in as 12, it goes in as 62. Do you guys have a sense of what I'm saying? Yes, Kenzie.
Drawing the graph, you put like 0, 1, 2, and then like make a cube.
Yes, you could. You could do it that way. You would still want to represent, when you're writing your equation, that the x values are representing in that way. You could do that. Do you guys understand what her question was? To actually use this information to represent along the x-axis? Because what you're going to be doing then is representing part C using the equation predicting the record for this year. Well, this year is what? It's 2014. So I will put in the number 14. So if you'd like, you can grab your calculators, put in the number 14. What is 5/3 times 14 and then plus 64? Okay, so it's 87.3, repeating, or you could say 87 1/3 inches. A lot of resources would tell you that you should write this as 87 inches because everything in your table was measured to the whole inches, so this would be measured to the whole inches as well. So if you wrote this as 87, that would make sense. What do you think? Are they going to jump 87 inches this year?
No.
That's a pretty big difference, isn't it? Yeah, anytime you go out of the data set that you're looking in, you're doing what's called extrapolating, which means that your answers are more subject to being wrong, okay? All right, one last thing then. We already talked about this, but we'll go ahead and write down the answers for these. Association, whether your association is positive, negative, or 0, depends on your what? Slope. That's all it depends on. Is the graph increasing, is the graph decreasing, or is the graph flat? So the first one has association. It's negative. The second one? positive, and the last one, there is no association, or you can say none. Or zero association would be the same thing, right? Because this y equals 8 is a flat horizontal line, flat. All right.